So let's be honest. How frequently do you think about the solid principles? Unless you are going through a recruitment process, likely you don't do it as much as many might think. And what if I told you that there's a small set of rules, really simple, that are more important than the solid principles for your day-to-day? So in this video, I will reveal which rules I'm talking about, why you must learn them before solid, and how to apply those rules in your day-to-day. But before going there, let me tell you that the topic of this video is covered in my test-driven development course that you can find at dotnet. So if you want to get into test-driven development, going from start to finish, you have my course available and you have the link in the description. And the good news is that if you are watching this video during the Black Friday week, you can go to dotnet and you can get that course or any other course in the catalog of dotnet with a discount of 40%, what is massive. And it's not only that, you can also get the bundles with a 20% discount. And those bundles are already under a discounted price. And how can you do that? It's quite simple. Just go to dotnet.com and use the code BlackFriday23 at the checkout. So let's get back into the video and talk about those rules that I was saying that they are quite simple and quite handy. But first, let me show you why learning the solid principles isn't enough. So when I started as a developer, I was not familiar with solid at all. I eventually learned it because everyone was mentioning it. I could find it in blog posts, conference talks, or even in a job interview. Someone would ask what is solid principles, what does it mean the I in solid, for example. So I have done my research and I learned what does it mean, the solid principles, where they come from, all of that thing. However, I have to confess that at first I didn't value them. I couldn't correlate those principles with what I was doing in my day-to-day. I couldn't see the benefits because I was quite fresh in the field. However, once the time starts going by and I have to maintain software that I've built some time ago, I start relating to the benefits of solid. And in different moments, I could relate the meaning of one of those principles, each one of those 5 principles, for a different reason. And usually that comes from failure. You understand that you have a design problem and now you correlate that information with the solid principles and now you can see why is that thing a principle. That's why there's a difference between knowledge and experience, right? And obviously I went through that phase where I was too dogmatic about them. They were the solution for everything until I started suffering with the principles itself. Why? Because even being foundational principles for us that we consider so important for everything, to a point that is the most common question that we'll get in an interview, they have a set of problems in there, okay? Let's go through them. The first one is that when we start discussing those principles, usually we will realize that there's a lot of ambiguity in the definitions that everyone uses. As an example, the SRP, the Single Responsibility Principle, is one of those where if you discuss with 10 developers, you will get 4 or 5 different answers from that group. So there's no common definition. Because let's face it, it's quite hard to define what is a single responsibility. I could even argue that for each line of code that you have multiple reasons for changing. The other problem is that they were designed for object-oriented programming. So if, for example, I'm a full-stack developer and I'm using OOP on one side on the back end and on the front end, I'm not following that paradigm. I'm doing a kind of a functional approach. I will not be able to apply solid consistently because it doesn't make sense. Not only that, but one of the principles is all about inheritance. And nowadays, we tend to favor composition over inheritance. So from the 5 principles, usually one of them will neglect it. And all of that makes solid a thing that we tend to be really nitpicky, for example, in a job interview. However, we will basically memorize the answers for everything, but then we can't correlate to them in our day-to-day. And if we combine all of that with the fact that is one of the typical questions during a job interview, that will make many of us to learn it for the sake of the interview. So we might memorize it, we might try to understand it, but correlating that with the reality, it might not be the thing that we are focused on. And all of those problems raise the question, there's any other set of principles that we can apply in a consistent way, that simplify our job, and everyone can learn them and master them? And the answer is yes, even outside of the object-oriented programming approach. So as you know, I'm always looking for simple things, not only in my personal life, but also in my professional life. So that puts me thinking, do we have any type of approach, any type of principles, rules, or properties, something like that, that we should follow that can simplify our life, that can be something so simple that we don't discuss the details of what it is. We don't have ambiguities. Something so simple that we all can memorize quite simple and apply in our day-to-day. Something so simple that will be the obvious tool in our day-to-day to get better design. And all of that without neglecting other approaches besides the OOP. And as you know, I'm a huge fan of test-driven development. And test-driven development will take you to Kent Beck. And then you will realize that Kent Beck has written those rules that I'm looking for long time ago. And he named them the 4 rules for simple design. So let's take a look into those 4 rules. So rule number 1, the code should pass all tests. What does that mean? It means that whatever you have done, it still works. So we are basically ensuring that we preserve the existing behaviors, let's say. Rule number 2, it should express intent. In other words, the code is easy to read and to understand. Rule number 3, no duplication. You know that duplication is the root of all evil in software, and you know the number of problems that it can impose into maintainability. So this rule will help you to eliminate all duplication. However, there's a clause here. You should strive for no duplication as far as it doesn't impact with rule number 2. If it affects the readability of the code, you shouldn't do it. And rule number 4, you should minimize the number of classes and methods. Or using in other words, you should remove anything from that solution that is not strictly necessary to achieve your goal. You are striving for simplicity. And one important detail about this rule is that you should remove anything that doesn't serve the previous rules that we discussed. And the cool thing about those 4 rules is that they are not only quite simple, but they have an order in place. So there's priority there, and it's clear to you when you should favor one thing over the other, because sometimes the decision is tricky. Sometimes to remove duplication, you need to bring complexity into the code, for example. But does that mean that we should replace the solid principles? So, solid principles still have a lot of benefits, especially for those that are in an OOP environment. If you are using C# or Java, it's a good idea to learn them. But now if you go back in your career and you start thinking about the amount of things that you had to learn at the time, and also you had to learn the solid principles, and you couldn't match those principles with the benefits because you never suffered with those decisions, now the solid principles look like that type of theoretical idea that you don't apply in your day-to-day. So instead, why not assume that the first step for building applications with an elegant and maintainable design is learning something more simple than the solid principles. And that's where you bring the 4 rules for simple design. They both, either the 4 rules and the solid principles, are targeting well-designed applications. But the benefit on the 4 rules is that it's simpler. You will already gain confidence. You will learn to write testable code. You will learn to think about running the tests a lot. You will ensure high standards in terms of readability. And during the process, you will also learn the dry principle. And I honestly believe that when we ask, for example, junior developers to start by the solid principles, we are not helping them. So my suggestion is that you start by guiding them to push them to the 4 rules of simple design. Once they learn them, they are comfortable with them, they have now that skill and that way of working, now it will be quite simple to introduce them to the solid principles. It will be kind of like a power-up to the skills, and they will step up in their career for sure. However, let me tell you that none of the things that I told you so far will be as impactful for a developer as learning to write tests first. So if you are interested in that, make sure you watch this video right here, where I show you an introduction to the process of test-driven development.